This lecture is going to teach you about molar mass and molar volume and how to do calculations with them. So remember back, right, a mole is just 6.02 times 10 to the 23rd, okay? And so keeping that in mind, in chemistry, when we're talking about mixing together chemicals, we're usually not going to be counting them in individual particles. We're going to be counting them in moles, okay? So let's start with the molar mass. What is the molar mass? The molar mass is just the mass of 1 mole of an element or the mass of 1 mole of a compound. Okay, so let's take, here's potassium. Here's a picture of potassium. You might not have ever seen it before. And so how do we figure out the molar mass of potassium? Well, you just look on the periodic table. And if you look at the bottom of the square, under K, it says 39.098, and that's its molar mass. 1 mole of potassium has a mass of 39.098 grams. So that's its molar mass. So that's really easy, huh? So for any element, its molar mass is given to you on the periodic table. Great. What about compounds? Okay, well, let's take potassium, combine it with chlorine, and make potassium chloride. How do we figure out the molar mass of potassium chloride? Well, we're going to look up potassium's mass on the periodic table, and we see here that it is 39.098, and we look up chlorine's and it's 35.453, okay, and potassium chloride is KCl, plus 1 minus 1. Okay, so we're just going to add those two numbers together. Now, one thing I want to note, you'll see here that I've written out the whole mass in the periodic table, and here I've written out the whole mass, but down here I've rounded them. And as it turns out, when we're doing these calculations, you don't have to keep all these decimals. You should round to 2 decimal places, okay? So 35.453 becomes 35.45. Pretty simple, okay? This one, however, when we're rounding to 2 decimals, 0.098, well, that 8 bumps up this 9, and then this 9 then bumps that up. So this ends up being 39.1, if that makes sense. So we're going to round to the hundredths, okay? And so then when we take potassium's mass plus chlorine's mass and we add them together, we get an overall mass of 74.55 grams. Great, so that is potassium chloride's molar mass. What if we have potassium sulfide? Okay, well, potassium is +1, sulfur is -2, so we need 2 potassiums to balance out that sulfur, so the formula is K2S. So again, we'll go to our periodic table, we'll look up the masses, and here's potassium's mass, 39.098, and sulfur's is 32.066. But we have 2 potassium, so we're going to have to take this and round it right to the hundredths, which ends up being 39.1, and multiply that by 2 because it's K2S. Okay, so 39.1 times 2 is 78.2, and now we add that to sulfur. So I've just taken this number and I've just moved it down here. Okay, so there's my 2 potassiums plus, here's my 1 sulfur, again rounded to the hundredths, and we add these two together, we get 110.27 grams. Okay. What if we've got something like magnesium hydroxide, okay? Hydroxide is a polyatomic ion, it's OH, and for magnesium, which is +2 and OH is -1, you need 2 of them. So here's my formula, MgOH2, okay? So magnesium's mass rounded is 24.31, oxygen's mass rounded is 16, because 15.999 would round to 16. And here's hydrogen's mass, so that would round to 1.01, okay? So the way we would figure this out, here's what I would do, is I would take hydroxide, which is O plus H, and so I would do this math right here, and 1 hydroxide is 17.01 grams, but there's 2 hydroxide, notice OH2. So I'm going to take that 17.01, I'm going to times it by 2, and so here's my mass for my 2 hydroxides, and then I'll just add in, I just transferred this right down here, and then I'm going to take my magnesium's mass, and put it right here, 24.31. So I add magnesium's mass plus the 2 hydroxide masses, and I get 58.33 grams. That's the molar mass, okay? So that's some examples of how you can calculate molar masses for polyatomic ions, for things where there's more than one element, okay? So hopefully that seems not too bad for you, okay? But now we're going to try to actually do a little bit of math with that. I know you're saying, weren't we already doing math? We were, but stick with me here. What if I don't only have 1 mole of a compound? Like, what if I have 2.5 moles of something? What's the mass of that? Here's what we're going to do. First thing you got to figure out the formula. Lithium hydroxide is going to be LiOH. Li is +1, OH is -1. Okay, second thing we're going to do is we're going to figure out the molar mass. Okay, so Li plus O plus H. Again, all of these have been rounded to the hundredths. I add that up, I get 23.95 grams. Great. Okay, so now step 3 is, yes, remember these from your mole lecture? I'm going to set up my cross chart. And so now I'm going to do my conversion here. What do I always do? I start with what I know that goes on my upper left-hand corner, 2.5 moles of LiOH. What goes on my upper right? The thing I'm trying to get to. I'm trying to get to grams because, of course, mass is in grams. Okay, and what's the only number I know about mass of lithium hydroxide? We just calculated it, 23.95 grams. And that's in how much of it? It's in a mole because it's the molar mass. Okay, and so now, of course, just like always, my units cancel. Notice my moles are on top, moles are on bottom. That cancels, so that leaves me with grams. Great. And so what math am I going to do here? They're side by side, so I'm going to multiply. And so when I multiply, that gives me 59.88 grams. Hooray. Okay. But what if we want to go the other way? What if we know how many grams? We want to find how many moles. Okay. We're going to use lithium hydroxide again to keep it easy. And if we got 21.6 grams of lithium hydroxide, how many moles is that? Okay. So step 1, I'm going to figure out my formula. I already did this before. I'm going to zoom through this. Step 2, figure out the molar mass. I already did this before. Okay. So I'm not going to explain that again. Step 3, I'm going to set up my chart. What goes in my upper left? What I know, what my problem gives me, which is 21.6 grams. What goes in the upper right? What I want to get to, which is moles. And then, of course, the only number I know that has moles and grams in it is the molar mass. Okay, so I've got 23.95 grams in a mole. And so, of course, here my grams cancel, which leaves me with moles, which is exactly what I want. And so what math would I do here? I've got one on top, one on bottom. I'm going to divide. So when I do that division, I get 0.9 moles, which makes sense, right? Because 21.6 is a little bit less than my molar mass. So that makes sense. All right, the next thing we're going to talk about is molar volume, okay? What if I wanted to know how much space, the volume, that 1 mole of gas takes up? Okay, well, you know how the mole is always 6.02 times 10 to the 23rd? Well, 1 mole of gas is always going to have a volume of 22.4 liters. Any gas, doesn't matter what it is. So you can memorize that number, 22.4 liters, okay? It's true for all gases that are under 1 atmosphere pressure and at a temp of 0 degrees Celsius. This is called STP, standard temperature and pressure. You will always be given gases at STP, so you don't need to worry about that. So the number that you need to know for volume is 22.4 liters. Okay, so how much space does 1 mole of oxygen take up? 22.4 liters. How much space does 1 mole of CO2 take up? 22.4 liters. How about carbon monoxide? 22.4 liters. It doesn't matter, okay? So it doesn't matter if it's O2 or CO2 or CO, because they're all gases, they all occupy 22.4 liters if there's 1 mole of them. Okay, so that's really, really simple. Now we're going to try some basic math here, okay? So what volume does 3 liters of gas occupy? Okay, we're going to set it up just like always. We start with what we know in the upper left. Where we want to get to is the upper right. What's the only number we know with liters and moles? It's my 22.4 liters in 1 mole. Okay, so here again, my units cancel out, which is what I want. And so now, once I do that, I'm going to multiply 3 times 22.4, and I get 67.2 liters. Hooray! Okay, last little bit here. What if I know how many liters and I want to get to moles? Again, I set up my cross chart. I put what I know in the upper left. I put what I'm getting to in the upper right. How many liters is in a mole? Always, always, always 22.4 liters, right? And then, of course, I can make sure that my units are canceling. They are. Now we've got this one above this one, so that means we're going to be dividing this time. So after I do my division, I get about 1.23, which makes sense because 27.6 is a little bit more than 22.4. So I should have a little bit more than 1. So that's how you do some basic setup of problems with molar mass and molar volume.